Hello, this is a sample of the problem that you had for class today. We all had different values. So here's the mass right here given. That's the mass. You're going to have to change that to kilograms by dividing by 1,000. Right here is VO, the original speed. Right here is theta, and I have 21.7. Okay, right here is the acceleration due to gravity, little g, on this planet. Well, mine is easily 10. You had something else. I mean, it could be anything depending on what the planet's gravity is. So they gave me 10, which we're used to. Don't use 10 if you're given some other acceleration due to gravity. Okay, right there is the coefficient of kinetic friction because this block is moving up the hill, up the incline. So that's the coefficient. It's not friction, it's the coefficient of friction. Okay, so we're supposed to find the distance, delta x, and the time it took to get to the top. Okay, now it stopped at the top. So we know VF equals 0 at the top, and then it's going to turn around, go back down, accelerate back down, but we don't have to do that part of the problem. Okay, so next we have to draw the free body diagram of the situation. So here's the angle that they gave me. For me, it was 21.7. Okay? You don't have to write the value. I'm just doing that. Okay, right here is a normal force perpendicular to the surface. I'm going to make that the box, that dot. Going straight down is the weight of the box. Right here, between the y-axis and the weight, is the ramp angle, the same angle as which I just drew right there. Okay, you got to remember that. Right here, I'm going to do the x and y components of the W. Okay, that's WY, and that's WX. Okay, so now there's nothing pulling up like in lab, like a string was pulling it up or holding it back, so there's none of that. But since it's moving that up the ramp, you got to realize that friction is pointing that way. Kinetic friction. So there's an arrow pointing to the left. Let's call that friction, kinetic friction. Okay. So this is different than what we did in class because in class we never had two forces on the same side horizontally, but that's the way this works. And I'm sorry, I didn't label the normal force pointing up. So that's all the forces acting on this. So let's continue. Okay, so what's the angle between the weight and the y-axis? So let's look at that. Well, for me, it's the ramp. For everyone, it's the ramp angle between y, the weight right here, the weight right there, and the y-axis the the y-axis right here. This thing going across like that. Okay, that's the ramp angle. And so I don't need to calculate that. That's, for me, is 21.7. Okay? So I'll just write the ramp angle because I'm not going to do the math to save time. Okay, what's the angle between W and the x-axis? So you don't. That's what I prefer to do. Let's call that theta 2. Well, it's just the complement of the ramp angle. So theta 2 is equal to 90 minus the ramp angle. Up here, this was theta 1. Let's call that theta 1, just plain theta. Okay. Okay, what's the weight of the box? The weight of the box. Oops. The weight of the box is the mass in kilograms times the G that you're given. Now, for me, it's 10. For you, it's whatever they gave you on the front page. Okay, where is that again? It's right there. Now, you have a different value. Use that value on that planet. And don't forget the mass is in kilograms. You can't use grams. So you see right there, don't use grams, use kilograms. Okay, so that's your answer. What's the x component of the weight, Wx? Well, you can use theta 1 or theta 2. I like to use the angle from the x. So that's Wx is the weight, which you just found up there, times cosine of theta 2, if you want to do the angle from the x-axis. Or you could do Wx is equal to sine of the ramp angle, because the ramp angle is from the y-axis. So what's the y component of the weight, Wy? Well, it's just like what we just did. Wy is equal to W times sine of the angle from the x-axis, or is equal to the weight that you found over here times cosine of the ramp angle. You take your choice of what you want to do there. Okay, the next thing you have to find is a normal force. Normal force. Now, if you do your free body diagram correctly, you would see that the normal force right here has to equal the y component of the weight, because the box is not gouging, accelerating into the ramp or accelerating off the ramp. So normal force equals Wy, and guess what? You already have Wy over here. If you go back here, you already have it over there. So that wasn't a big deal. Friction is equal to the coefficient of friction times the normal force. Well, the normal force is Wy. Coefficient of friction is given, like I showed you on the first page. It's given right there. And that would give me the friction. Now, this is where people messed up right here, I think. This is the major mistake people made. the net force on the box. Let's go back to the picture. If you look at your horizontal forces, you only have two of them, and they're in the same direction. So they have to add up, not subtract. The net force equals Wx plus friction because they're going the same direction. So Wx was, let's show you how to do that right there. And the friction we just found right there. Okay, so that's easy, but add, don't subtract. So that's where you fell apart, I think. Because if you miss this, because you didn't see it in your free body diagram, then everything else falls apart. I mean, you do the right equations, but it won't match the right answer. So use second law, net force equals ma. You got the mass already. Some of you guys, a lot of you guys, thought this A was G. A is the acceleration of the block as it slows down. It's not G. It's what I'm trying to solve. It's the rate that the box is slowing down as it goes up the ramp on its own power with no thrust. Okay, so solve for A. A equals the net force right there that you solved there over the mass in kilograms. So that's really easy for your units into. Okay, next. Calculate the time it will take to get to the place it stops at the top using a kinematics equation. Okay, so we got the A, we got the acceleration of the block. Oops. We got the acceleration of the block down there in the last problem we did. Okay, so calculate the time it takes to get to the top. So VF is 0. VO is given. It was given at for me, it was 4.65 meters per second. It was given. Okay, what else do I know? I know the A. That was just solved in right here. Right here. That was just solved over there. So you got the acceleration calculated before. So simply use this equation, big deal. A equals VF minus VO over T. Simple acceleration equation. Change V over time. Okay, that's going to give you a negative answer, which is okay because it's going positive velocity and it's slowing down, so acceleration will be something negative. And then to do the distance, delta x, let's see, let's try this one, VS squared plus VO squared, wait, delta x equals VO t, wait, that's not it. I'm not remembering it right. Let's do this one. VF squared equals VO squared plus 2 A delta x. Okay? VF squared is 0. So VO squared is given. You have sorry, you have A up here. Okay, I'm just going to backtrack a little tiny bit here. We're solving for time up there. I'm sorry, I forgot that. We're solving for time up there. So t equals VF minus VO divided by A. Now, this is going to, the denominator is going to be negative because he's slowing down for the reason I just told you. You're slowing down and you're going positive. So this A that you solved over here, you got to make negative. Because when you do kinematics, it matters. When you do dynamics, it doesn't. But we're doing kinematics right now in this part. Okay, so when you plug it in here, be sure it's the negative answer from when you found it there. And so that works out really easily to solve for delta x. Okay, so I think your major mistake you made was right here. Okay, so hopefully that really clears things up. And I really want you to grapple with this and not tell you how to do it until you struggle with it a little bit, because that's how it will stick. Okay, so hopefully you can now do yours over again and send it in. Submit it again. You have till Friday to submit it, but I think you can do it tonight if you have time. Okay, so thanks for working on it when I'm not here.